Hello students, now we are going to start 16th unit of crash course, which is ray optics. So we divided this unit into two parts. One is reflection, second is refraction. So first we will discuss about reflection. Reflection means light is bouncing back after striking a surface in same medium. If it is entering into another medium, it is refraction. So first we are talking about reflection through plane surface, means plane mirror. If you take a glass slab and polish one surface, what you will get? Reflection. If surface is smooth, then it is known as regular reflection. If surface is rough, we will say irregular reflection. What is difference between regular and irregular reflection? If a beam of parallel rays is coming towards mirror, after reflection, if again rays are parallel to each other, it means it is a regular reflection. If it is not, then irregular reflection. The ray coming towards the surface or mirror is known as incident ray. It is normal. It is reflected ray. Two laws are there known as laws of reflection. Angle of incidence means angle between incident ray and normal. It should be equal to angle of reflection, means angle between normal and reflected ray. I and R are equal. Either it is regular or it is irregular reflection. Angle I is equals to angle R. Rule number 2, second law. Incident ray, normal and reflected ray, they should be in same plane. Means it is not possible that if incident ray and normal are on this paper, reflected ray will come out. So these are two laws, and I is equals to R. What important this? Only one mathematical law is there. I should be equal to R. So in any numerical, we have to take care of this only. Now some points for need purpose you should learn. If you want to see which type of questions they can ask you in a plane mirror, first we are discussing that. If you want to see your full image in plane mirror, you need a mirror of half of your length. It was in your syllabus in 9th, 10th class, and it doesn't depends upon the level of your eye. It is independent of that. Means if your height is 6 feet, to see your full image, you need at least mirror of length 3 feet. First thing. Second thing, object distance should be equal to image distance. It means if you put an object at a distance x in front of the mirror, you will get its same size image at same distance behind the mirror. Regarding this, they can frame like this. If you are moving towards mirror with a speed u, with what speed image is moving towards you, second they can ask towards mirror. C. Speed means distance travelled in 1 second. If in 1 second you travel a distance d towards the mirror, your image will also travel a distance d towards the mirror. Means your image is moving with same speed towards the mirror, but towards you, its speed is different. In 1 second, you come closer to mirror by a distance d. Image come closer to the mirror by a distance d. It means between you and image, distance is decreased by 2d. In 1 second, distance decreased by 2d. It means image is approaching to you with double speed. If you are moving towards mirror with a speed u, image will move towards you with speed 2u, but towards mirror it will be u. Take care of this. Third thing, if you have two mirrors inclined at some angle, say theta, you will find more than one images. How many images you will find? You can calculate by this formula. Divide 360 by theta. If you are getting n and n is equals to even, you will get number of images n minus 1. But if n is odd, you have to check the position of object. If it is symmetrical, you will get n minus 1 images. But if it is asymmetrical or non-symmetrical, you will get n images. What do you mean by symmetrical? Symmetrical means object is placed on angle bisector. If it is one mirror, it is second mirror, and it is angle bisector. Means this angle should be equal to this angle, angle bisector. If your object is situated at angle bisector, then we will say it is symmetrical to both mirrors. If object is on this position is symmetrical. And if not on this, any other place, it is non-symmetrical, near to 1 and far from second. So they can ask problem based on this. Third concept they can ask, if you are rotating your mirror by an angle theta, if mirror is rotated through an angle theta, a reflected ray, it will move through an angle 2 theta. It will move through an angle 2 theta. So only you have to take care of these 3-4 things. If you want to see full image of yourself, you need a mirror of length which should be half of your length. If you want to see complete image of yourself, you need length of mirror should be half of you, and this length is independent of the position of eye. Sometimes to confuse you, they can say your height is 1.6 feet, 1.6 meter, and eyes are at the height 1.4 meter. What length of mirror you need to see your full image? So no effect of position of eye. So you have to learn these things regarding plane mirror. We were discussing first plane mirror. If you have a thick plane mirror, they can ask which image is the brightest one. If we have one thick plane mirror, means it is a polished surface, it is a glass slab, you polish this. Remember always, reflection is always 100%, but refraction is never 100%. What do you mean? See, suppose 100 rays are coming with this beam. 100 rays are coming towards this thick mirror. Mostly will refract. Suppose 90. Some will reflect. Suppose 10. So first image is formed by these 10 rays. Now after reflection, 90 rays will move toward this. Again refraction will take place. Mostly rays will refract. From 90, suppose 80. Again a small number. It will reflect. It will reflect. Some rays will reflect, suppose 10. So your second image is formed by these 80 rays. Again reflection is 100%, all 10 move towards again surface. Mostly will refract, suppose 8. 2 are reflected. So third image is formed by 8. So what we are observing, that the brightest image is second one, because 80 rays out of 100 are taking participate to form this image. So second image is always brightest image in case of a thick mirror. Now we will discuss about concave mirror, means reflection through curved surface. Reflection through curved surface. What is happening in curved surface? Means you have a sphere of glass. This was sphere of glass. Its radius was r. You cut apart from it. So now we have one part. If we are polishing inner surface, it will become convex mirror. If you polish outer surface, this name of this is concave mirror. And if you complete the whole sphere, the radius will known as center of curvature. Now we will discuss about this curved mirror. If outer surface is polished, it is concave mirror. for both concave and convex. If you complete the sphere and its center is this R, it is center of curvature. It is known as center of curvature. At half distance, and this geometrical center is known as pole. Half of the distance of radius of curvature, you will find focal length. In 19th class, you have proved this result. It is focal point. Means magnitude wise, R is equals to always 2F. Line joining pole and center of curvature is known as principal axis. Rays which are coming parallel to the principal axis. After reflection, cut the principal axis, at which point it is known as focal point. Always we are using one sign convention, which is like coordinate system. Means take pole as origin, measure axis as x-axis, and line perpendicular to measure axis at pole is known as y-axis. You know that from P to right side, all distances are positive, and from P to left side, all distances are negative, and lengths which are upper side of the measure axis are positive, and downside they are negative, because y coordinates in downward direction is negative and upward direction means upper than x-axis, these are positive. Suppose I have one object and I find its image like this. It is object, it is its image. So what we will say, length of object is positive. In this case, length of image is negative. Object distance means from P to object. This distance is known as object distance, denoted by U. From pole to image, this distance is known as image distance. And relation between focal length, object distance and image distance for all type of mirrors is 1 upon F is equals to 1 upon V plus 1 upon U. This formula is known as mirror's formula. If distances are on left side of P on x-axis, they should be taken negative. If they are on right side of P, they should be positive. Lengths on upper side of x-axis are positive and down side of x-axis are negative. And for magnification, for mirrors, for both mirrors, we have formula M is equals to minus V by U. It is formula for magnification, means length of image upon length of object. When you are going to solve any numerical, if some physical quantities are given, take with sign, but never put sign for unknown. You will get this sign in your answer. It is the rule to solve a numerical. Which is given, only put them with sign. If you know that final image is inverted, it means magnification should be negative. The size of image is negative, size of object is positive. So it means we have to put value of M negative. But if you are going to calculate M, don't put its sign. It is real image, so it should be this. It is virtual, it should be this. Don't go for that. The images which you find behind the mirror are known as virtual images. Images which are in front of the mirror are real images. Where you will put object, where you will get image, you can learn by this formula. For convex mirror, first we are talking for convex mirror. All images are virtual. Virtual means behind the mirror, erect and diminished. Virtual, erect and diminished. For convex mirror, but for concave mirror, it depends upon the position of object. Now, on principal axis, there are these three main points: pole, after pole focal point, after that center of curvature, means point at r distance from pole. R means radius of curvature. After that plus infinity is there. So if object is at infinity, if object position is infinity, you will get its image at focus. What is the nature of image? Nature is point size, real. All real images in lens or in mirrors are inverted. Real means inverted. It should be inverted. You will find a point size image which is real and inverted. If you shift object between optical center and C, image will shift and it will be between center of curvature and focal point. You will get image here. It is diminished. Diminished means size of image is less than the size of object. It is real. It is inverted. If you put object on C, you will get its image on C only. It is equal in size. Real and inverted. But if you keep the object at focus, what we did, first step was infinity, object infinity, then between infinity and C, then we put it at C. Now between C and F, we are putting object between center of curvature and focus. You will get image between infinity and center of curvature. Now it is enlarged. Real and inverted. But if you keep the object at focus, fifth point, object at focus. I am writing here If you put object at focus, you will get image at infinity. It is very big in size, real and inverted. It was a list for concave mirror, but if you keep the object between focus and pole at this place, you will get image on other side. It will be virtual, erect and magnified. It was a complete list where we will keep object, where we will get image. And numericals are only based on these two formulas. After that, we will discuss now refraction. First, through plane surfaces. Then we will discuss curved surface. What is important in refraction through plane surface? It is first medium, it is second medium. It is normal to the boundary. Incident ray, due to change in velocity, you know that in a rarer medium, light travels fast. In a denser, its speed will decrease. Due to change in medium, it will bend. When it is moving from rarer medium to denser medium, it will bend towards the normal. And this phenomena is known as refraction. It is angle of incidence, it is angle of refraction. Snell, one scientist, gave two laws regarding this refraction. First was this, that refracted ray, incident ray and normal all lies in same plane. All lies in same plane. Second was this, refractive index of second medium with respect to first, it should be given by sin I by sin R. Means if you increase the value of I, value of R will increase. If you decrease the value of I, value of R will decrease. But ratio of sine of angles will remain same. It is the definition of refractive index also. What do you mean by refractive index of second medium with respect to first? You can write like this or you can write like this. Either first medium on upper side, second on down side, or first medium on left hand side, second on right hand side. Refractive index means the ratio of speed of light in both medium, means speed of light in air upon speed of light in medium. But we know that speed is equals to frequency into wavelength. When light enters from one medium to another, there is no change in frequency. It depends upon source. So frequency will cancel out and you will get lambda A by lambda B. Means wavelength in air upon wavelength in medium. So it was the definition of mu. There are two definitions. One more definition we can make. What will happen if you see through a denser medium? Means it is water tank. and you observing the depth. What should be the depth of tank? Suppose you are here. I am not making your eye on this to make diagram, little bit side. When the ray will try to enter the medium, since rays are moving from rarer to denser, rarer medium to denser, what will happen? When rays are coming from rarer to denser, they will move towards the normal. And if you put some object at this place, I am now reversing the direction of rays. Rays are travelling from this point to your eyes. What will happen then? If rays I am taking from water to your eyes, now they are travelling from denser medium to rarer, they will move away from the normal. It means for your eye, rays are coming from this point. So you will find the image of this point at that point. Means for you, O is at eye. It means when you are looking in a water tank, you will find the depth is less, because the point which was at depth, now it is at some height. So for you, depth is not equal to real depth, it is less than that. Means for you, apparent depth is less than the real depth. If this angle is I, it should be R. Vertically opposite angles are equal. So if I am taking this angle I, this angle should be I. If this is R, this whole angle is R, means this angle will R. This distance I am saying A, this distance I am taking B. What is mu? Refractive index. Suppose this is water. Refractive index of water, rays are travelling from water to air, is equals to sin I by sin R. But for small angle, sin theta is equals to tan theta. So we can write it tan I by tan R. Tan I means perpendicular upon base. What is perpendicular? A. Base means B. A by B. What is tan R? Perpendicular A. Suppose this distance is H. A by H. So what we are observing here, W mu A is H by B. So A mu W, it should be B by H. What was B? B was real depth. What is H? H is apparent depth. So in this way, you can find if I am seeing ki depth is about 3 meter, what should be the correct value if I know the refractive index? So you can solve this type of numerical. If refractive index of water is 4/3 and real depth is 4 meter, what should be apparent depth? 4 into 3, 12, 12/4. What should be the apparent depth? Apparent depth is equals to 4/4/3. If real depth is 4 meter, you will see it 3 meter. So that's why it is risky to jump in water only by observing that it should be the depth. Real depth is always greater than apparent depth. If you are observing that it should be 3 meter, but in actual it is 4 meter. So this relation was very important, and sometimes they are asking question on this. Now we will discuss when rays are moving from denser to rarer, what will happen if angle of incidence will cross a certain limit? Means we are talking about critical angle.